recording.
Oh, thank you very much. Sorry to interrupt.
It's okay. Okay, so I'm not going to go into very technical details about the code and what we did technically in this kind of database. This is not the goal of this talk. Of course, I'm available later and even by email whenever you want to speak about the itty-bitty gritty technical details. What I would like you to remember after this talk is why there is the need of an ICT platform, of an ICT infrastructure in this kind of project, why we consider it to be the medical legacy, and how this is a very important part of to take into account when we talk about the economic sustainability of a climate service. So let's start from the beginning, which usually is a good idea, good place to start from. This is the ICT platform. I'm not expecting you to understand every single component of it. The goal of this slide is just to represent you that it's a complex ICT system with a lot of components. Some of these are storages, databases, and procedures, connection to external services. It's a very complex piece of work. So why did we decide we needed to do all of this in order to be successful in MedGold? Let's start from what MedGold is about. MedGold is about turning climate-related information, which means scientific knowledge, into added value. So it's about turning knowledge into operational tools and data that can be a real value for the agri-food sector, and specifically for these three traditional Mediterranean crops. This is what we are aiming for. So a great part, I think the vast majority of this information is already available from the Climate Data Store, which is an official climate repository financed by the European Commission via the Climate Change Service. I don't want to go into details here, but it's already there. If you go there, you can. I think maybe you did it during the workshops. I'm not sure, but this is where the data comes from. So you will think the easier thing, if you want to do something with this and come up with value, will be that every researcher, everyone who is developing something like you are doing during this living lab, just uses their own computer and connect to the site, download the data, and make script, maybe download some script that the project has done, and this worked. This is basically how we did during the project, to be honest. The researchers do just this. They download the data, they try to make order out of the chaos that is climate data. They come up with solutions, they share it between them. This works when you're developing a project with 20 researchers. They are all experts in this field. They know how to treat climate data coming from the Copernicus data store. They know how to do the conversions, the processing, and so on and so forth. But if the project is successful, we should expect more users, and hopefully a lot more users. And this starts to be a problem. First of all, these stakeholders, these people we are trying to create value for, are not field experts. They might not know, and in fact, they do not know how to convert the data. And even if we make scripts, it's not easy for them to just download the script we made, do everything that's needed to make it run, download the data. It's not an efficient solution. It's not a way to provide real value to people whose livelihood is not downloading data and making scripts, but it's making wine, making bread, making pasta, or making policies. It's a matter we say in the ICT field, not only the ICT field, but it's a very important topic in the ICT field of scalability. The scalability means having a system, whichever system it may be, that is capable of growing as the demand grows. So this kind of system, which is here is the scripts we made, download them, figure out how to run them, and good luck. This doesn't scale well. It only scales when all the people involved are expert in the fields and have contributed and making those. When things start to grow, this doesn't scale. Just a quick metaphor, a silly one, but if you want water and you've got an available source of water, let's say a spring or a well, the quicker thing is just grab a bucket, fill it with water, there you go. This stops to be easy when there are 2,000 people around the well with a bucket. They all want water. And maybe they don't just want one bucket of water. They want one to cook pasta, five to clean the kitchen, 10 to... In other words, the bucket distribution system for water doesn't scale well. And we all know that what do we need if we want people to have access to water in a scalable way? We must build an infrastructure. And that's exactly the same. It's data. It's data instead of water, but the idea is the same. When you are at a certain level of complexity, when you scale up at some level, you need to build an infrastructure. Now, building an infrastructure, this is much more complex than this. I think it's clear. It's much more expensive than this, but it allows you to scale. So that's why we made this. That is clearly not as simple as a script. This is our pipes, our infrastructure. Just a few more words about the concept of scalability. The easier way to scale in ICT is just by a larger computer. You all know, if you like, I don't know, gaming, that the new game requires more processor. You buy a new processor, you buy a new video card maybe, and you make your computer into a Ferrari. This is called vertical scalability, just making the computer faster, stronger. And this has limits. This has limits because there is a limit to the technology, to the integration, to how fast the processor can be. And of course, this doesn't solve the problem of what happens if the single computer you're using, how strong it may be, fails. Not if, when. It's just a matter of what. So the concept we use nowadays is that of horizontal scalability, which is having more computers, more machines that work together to serve a large number of users to solve large problems. Of course, this is more complicated because if you install, you know very well, if Word is slow on your computer, you buy a faster one. You don't have to do anything to Word. It just runs faster. In order to have an application, a system work in a distributed way, so in more computers, there is a lot of work to do. I don't want to delve into details, but here the message is we want horizontal scalability is the only viable one, and it introduces complexity because you can't run Word on 10 computers and expect it to run faster per se. If you're just running, and it's pretty much the same. You must adapt the application. By using horizontal scalability, you also start to solve other problems, and those are of high availability, fault tolerance, and so on and so forth, because you don't have all of your eggs in one basket. You've got a distributed system, so if any single component fails, you still can go on. That's why this looks so complicated, because it is, because we are implementing this concept at every step. All single components, all data stores, all databases, all web servers must be horizontally scalable, which means adding a lot of complexity, but allows you to serve an infinite number of users, given you've got infinite money, of course. There are another kind of scalability I want to talk about. It's some kind of functional scalability. What do I mean by that? This is in very, simplified way what the ICT platform does. It provides storage for the climatic data. It does some processing, some computing of indices of stuff that we think will be useful for the agri-food, and then some kind of export. It may be a text export, it may be image exports, graphs, whatever. But returning to the principle of providing value, which is the philosophy, the mission of the project. Let's think of three users, in marketing they call them personas, which means just fake people you make up in your mind to start and think who will be using my system. And I just wrote three. These are three stakeholders that we are really considering in MedGold. Do you think value for these three people is the same? If you ask to an olive oil producer in Italy, what would be useful for you? I think his answers would be different from a policymaker in Berlin. They need different data. They need different views. They will use the system in different times. Maybe he wants to know when to give treatment to the plants, and she wants to know whether she should make laws to, I don't know, start subsidizing olive or some other kind of plantation. So there are different ways to provide value to different kind of users, and we must cope with that. We cannot just give them a web page and say this is all, go figure it out. So we must scale also in functionally. We must be able to give different kind of value to different kind of users. How do we do this? The way we think about our ICT platform is just like a highway. A highway has different exits. You can go from start to end, use it all the way, but you can also exit and go out first, because the highway helped you cover the road you needed and not more. And so if we go back to this is our data highway. This is, it's a bit 90s way of describing an ICT platform, but okay, this is our highway. We need the users to be able to use it all the way, to do all the steps, or I just need a storage. I need the storage, and please could you do for me a very good bias correction and downscaling, and I just download the data. I also would like you to compute for me all these indices, and please provide me the export. Or no, I want the graphs, I want a web interface. This is how we targeted what I call functional scalability. We made different kinds of exits to our ICT platform, of exports, meaning we are striving to give every kind of user some possible value. If you just need a curated, normalized data sets, there is a way to do that. There is a part of MedGold ICT platform that just provides you that. You need processing. There is a processing infrastructure all the way to the dashboard that I'm sure you have already seen, which is you're using the whole thing. You're asking the ICT platform to do the storage, process, compute, and then give you the results in a graphical way. All of this is also implemented by, this is another important product we made, APIs, which means application programming interface, which are a way for MedGold to connect to other systems in a machine-to-machine way. If you want your decision production system, if you have, I don't know, a wine company and you already have a system, you may want to connect MedGold data directly to your system in a machine-to-machine way to make computers talk between themselves. And this is what APIs are for. And they are, I think, the most strategic part of the ICT platform. All the rest is built upon the APIs themselves, meaning the dashboard, we made it, but everyone else could, in the outer world, in the world out of Madgal, could have built it using the APIs. This is a very important point. So the last question is, this is all good, but we've seen the complexity grows, and this has a cost. How much does it cost? How much does having a piping cost more than buckets? Oh, I don't want to, of course, to give you pricing list or anything like that, but I want to talk about a concept that I think is very important. So why do we decided to use a cloud-based platform to implement all this? Imagine you are doing this with computers. You go and buy computers and place them in a room, start installing your ICT platform. So this is this blue line. This is what happens if you build this the traditional way. You buy computers, and you decide how many users you think you will have. You buy enough computers, and make a data center. This is how it's called. It's very expensive. The demand grow because Madgal is very useful. A lot of companies, a lot of users want to use it. Then you need to buy other computers. Your expenses grow like this. They're like stairs. If this is all waste because you are buying computers, you are building data center for customers that are not already there, but you can't under deliver because here your customers are very sad. The wine industry can't connect to the system because it's overloaded and it doesn't work. So with the traditional model, it's a fine line between spending too much and losing customers. And of course, all this blue line is what is called capital expense. You must make an investment beforehand. You must have money to build a data center, to build a system, to prepare. It's not easy to do. It requires investment, and it doesn't scale very well. The red line is the actual demand. It's what the users are doing with the cloud, with a system that is opportunely coded. Of course, it's not automatic, but what you can do is to have what is called elasticity. You can buy ICT resources on demand as soon as they are needed. If you made the application in a certain way, which we did. So the cloud demand is the yellow line, which you can see follows the red line, and this is all ICT resources you buy just when you need it. There is no capital expense; it's operational expense. So you are sure that you are only spending money when you have got users, and so revenue hopefully. So this is why, just to end my presentation, this is why we needed this much complexity to tackle this problem. We want to be able to have a system that can grow as much as Madgal has success, hopefully a lot. If tomorrow we have 100,000 users, I know the system will be able to bear that. If we've got money, I mean, we must have a business plan behind that. If we've got different kind of users, we build the system in a way that everyone can find their own exit and find something that will be a value for them. And in the end, we built it with cloud technology so that we know that this thing can be sustainable from an economic point of view without needing a very large capital investment at the beginning, but I'm sure Francesca will talk a lot more about this kind of topics. So I think this is all. I hope I didn't go too long with my presentation.
Thank you. Thank you very much, Federico. Quite useful, and the idea and the issue of the cost of climate service has been raised several times in the discussion of the teams. So I think that you have provided something that could be useful for the team. There is time just for one or two very quick questions from the audience.
Okay.
Oh, please,
No,
Federico.
no, I saw one. What does ICT stands for? But Massimiliano already answered. So yeah, sorry. We all given our acronym. We love our acronyms and we give them for granted. Sorry.
Is there any question from the audience to Federico, or everything is clear enough?
Okay. No, you froze again.
About the persona.
Yeah.
I have a question related to how did you approach the persona that you were tackling, and how can you find out about their needs and what they want? How often do you speak with them?
No, to be honest, for this presentation, I just made them up, knowing what kind of stakeholders we are addressing, of course, which is in the proposal. But I just came up with 3 names and 3 countries and 3 roles. But I knew the roles are roles we have been addressing for years, because we made a workshop with the policymakers, workshop with the winemakers, workshop with the. So it was more of a top-down approach on that. I think Marta could say a lot more about it, but for the sake of the presentation, I also came up with names. Is all.
And there are 2 hands raised by the first one by Luigi. Please, Luigi.
Yeah, Federico, thanks for your presentation. Very interesting as usual. A lot of insight that I got firsthand in this project that I wasn't aware before. So thank you again. I was wondering, and maybe of interest to the rest of the people attending, not for climate services in agriculture, but in general, when you provide a service that is based on a cloud infrastructure, what would be, I mean, in general, the incidence in terms of costs when you provide and deliver that kind of service based on data that is publicly available, but based on a cloud infrastructure? If there is, if you haven't, to give people an idea.
Yes, of course. This is, this is my daily life. It's what I do for a living. And usually the matter is when someone comes from a traditional kind of architecture, so a data center, they've got computers, they run their stuff on, and they want to go to the cloud. Usually there are a number of ways to doing it. The easy one is called lift and shift. You just take what's on the computers and install them off the cloud, and you end up spending twice as much. Because the cloud is not meant to be used like that. It's meant and this is why I said it's more complex to make applications for that, because you are making application when you work in the traditional way, assuming you've got a target kind of, I've got a computer this fast. So as long as it doesn't hang, it's okay. I save the files on the disk because I know there will be one disk. When you use the cloud, this is not true anymore. If you want to take advantage of the cloud, you have, for instance, the general idea is you must be able to split a given problem into small pieces so that all those small independent pieces can run on more computers when it's needed and run on less computers when it's not needed. So it does require some kind of adaptation. If you're willing to traverse the desert, to do this work, or if, like in MedGold, you're doing this from scratch and you do it that way, usually you end up saving a lot, orders of magnitude. There are, there are a lot of use cases. I remember one when I started with the cloud. AWS gave us, and it was a public sector. It was a research use case. I think it was fluid dynamics. I'm not sure about them. the details, but the matter is they wanted to do some calculation, and it was a British, I think maybe the Oxford University. They would have needed to build a data center that they couldn't afford. It was tens of millions of pounds. They couldn't. Nobody would have approved that, so no research. Using the cloud to do that, they just instanced thousands of computers for 2 weeks, which was the time they needed to do the calculation. They ended up spending £100,000, which is not peanuts, but it was feasible. So usually the cloud gives you a definite saving and more flexibility, but you must learn to think in a different way, to split problems in a different way, to approach problems in a different way.
Thank you.
Thank you. Thank you, Federico, and thank you, Luigi. I see that Tony has raised and then lowered his hand, so I don't know if Tony, you do want to add something for your question or not.
Well, I'm not sure. I'm not sure if this is the right moment to ask this. I was just thinking, when you scale something horizontally and you involve more people, I imagine every person has to deal with a more specific task, but needs to know what happens around them. And I was wondering if you could speak about how can we, as early career professionals, learn about adjacent fields and don't become siloed in our own field and our own expertise, but learn to work, with other people in a larger, more complex environment. If that makes sense.
Yeah, it makes sense. It's a very good question. I'm not sure I've got the answer. I think it goes a bit beyond ICT. I can say what I found in my life, but it's just personal experience. It's just my 2 cents, euro cents. And it's exemplified by this project. A lot of ICT professionals tend to focus a lot in ICT, which is right, because it's a complex field and you've got to specialize into the cloud. No, I only do this cloud provider. This is needed because you need very high skills. But I always found that having at least the curiosity of contamination with other fields gives you a lot. I learned a lot during this project. When I started, I didn't know the difference between climate and weather and a lot of other things. And my way to approach this is to immerse into a field. My colleagues know this. Of course, I'm not a climatologist. I'm not a field scientist, but I know more. And as such, I can see the problem more in the way that the users see it. And it was the same when I worked in healthcare. I started studying medicine, physiology, not because it was needed for that specific problem, but because you must immerse in the field. You must go a bit over your specific responsibility, because nowadays we are specializing like insects. We must be very laser focused in our professions, but I think having a larger view is important. But again, this is just my personal opinion on this.
Thank you very much, Tony. Thank you, Federico. Now I think that it's time to pass the witness to our to the other keynote speaker of this morning. I will present again Francesca, hoping that the connection is more stable. However, Francesca, do you prefer that I'll share the screen for you? Would be better.
Yes, but only because I think that if you do have questions in this way, I can see them while,
okay.
Because ideally for everyone who is connected, I'm very happy to take questions while you have them, because it's a stepwise process. So if you want to raise your hand or whatever, yes, you need to bear with me because it's a relatively long presentation, but not that long though.
Okay. And Thank you very much, Francesca. I will come back to your presentation. Francesca, as I said, is a researcher at CMCC. She works for on innovation for climate change. She is also near a completion of PhD in climate change science and management in the University of Venice, Ca' Foscari. And Francesca is an economist for her background, but she has a strong expertise also in physical science due to her PhD, and now is currently an appointed ambassador at the EU Climate Pact. And so it is a pleasure for me to introduce Francesca. And Francesca, thank you very much for your willingness, and I'll share your presentation so now, and the floor is yours. Thank you, Francesca.
Yes, so today we're looking at how to move from data to services, but having a perspective. There is more coming from the... I had the pleasure to actually work on these topics in a Horizon 2020 project that just finished, CLARA, Climate Forecast Enabled Knowledge Services, that we coordinated. We are sister project with Met Gold, so we actually walked along the same path for, say, almost 2 years or so. Yeah, you can move to the next slide if you want. The idea here is to focus on, ideally, to understand what climate services are in a market-driven context. So climate services are mostly at the intersections of innovation, Industry 4.0, which is now Industry 5.0 after the coronavirus, green economy, but also sustainability and knowledge economy. So we are at the center, basically, of this intersection, but everything framed within the market idea. Why? Because we can look at profit or not look at profit, but in the end, we are embedded in this market perspective where there is a demand on one side and a supply on one side. So to actually make these services scalable, we need to think also about the business models, business strategies, and business plans. In a way, climate services are very useful for at least 4 dimensions. The first one is the social one. Since they enter into the decision-making process, they change the decision-making process, and they actually support this idea of improving decisions with science. Then there is an economic value behind that is very difficult to assess. We're still in the process of understanding how to evaluate the contribution of climate services to the economy, but it's enough to say that since preparedness is boosted and resilience is increased of different assets, companies, and people, then we have a reduced amount of losses. So we are more prepared to face negative consequences of environmental factors or climate change. There is also a political factor that is often neglected, but is very important. Climate services democratize information. They normally transform relatively difficult raw climate data, which are kind of hostile information for those who are not very familiar with downloading from C3S and understanding how to include this data, and they make them available to a wider portion of the population. So basically, they're moving a wider range of users from a sort of ignorance veil to a knowledge situation. So having climate services on board within this is also very important to open up to a new knowledge where climate is becoming a very crucial variable in the process. And finally, is of course the environmental aspect, which, by the way, is not, again, often used even in research papers, because since we are including nature in the anthropogenic features of our society, we're actually including environment in our decision-making process. And this is, again, very crucial. Next slide, please. Now, as I said, ideally, we need to move from a concept that is very abstract to a concept where market matters. And one of the features that we can use is the business model. So in the literature, not climate service literature, the business models are the representations of a firm underlying core logic and strategic choices. So there's somebody, normally the CEO, in the board that are taking these choices that are strategic. So they're forward looking, but they're also very instrumental to enter a given market. And the set of all these choices, so all these strategies are business models that are aimed at capturing and creating value. So basically, the business model is a framework that designs and explicitize and shares with the rest of the world how a company creates, delivers, communicates, and captures value. So the core point is the value added that you're giving to somebody, the value added that you're giving to your context. Next slide, please. But in the case of climate services, business model are slightly more complicated for two big reasons. The first one is that there is a strong co-production process in place. I'm sure that you touched upon the co-production already through the Living Blab. So there is this constant interaction between the provider and the user. And if you think about other type of businesses, this is not necessarily the case. And the second is that sometimes, very often now, climate services are provided by institutional agents, so organizations that are not profit-oriented, that cannot make any profit by mandate or by their requirements. So business models serve to increment innovation, so they are the last step, basically, of an innovation chain that moves from local to systemic in terms of scope, but also that increases the amount of innovation that we are introducing in the systems. And specifically, business model for climate services entail the evolving logic, so is changing over time, is dynamically changing, of whatever institutional agents, which means private sector, public sectors, PPPs, so public-private partnerships, to co-create value with users and to promote innovation and support decision-making. How? By creating bespoke, so user-tailored knowledge services. It's enough to think about the difference between the weather services and the climate services. Weather services are okay for everyone. You open your app and everybody can access the same service. We're pretty familiar with the protocol that we are using with weather services. Whenever we see the sun, it means that it's going to be sunshine. And whenever we see drops, it means that it's going to rain. But there's not really a co-creation process going on. I will never talk to the, I don't know, to my military service in my country to actually create a better weather service for me. It would be, yeah, I could do it maybe in the future, but I should be at another point of the galaxy. But otherwise, weather services are basically the same for everyone, while climate services are not, because they're very user-tailored. They're very user-focused. So they have this evolving logic of co-creating value. Having these things in mind, we know basically what business models are, and we know now from this moment onwards in the presentation, we're learning basically what steps ideally would you take to actually run from data to an operational and market-driven services. Next slide, please. So again, ideally, when we're thinking about the business models, we're thinking about one step of the overall process. It's not something that is functional to something else. It's something that is a standalone, because we're sustaining innovation within the framework, for example, of the European Union with the Horizon Europe or the Horizon 2020. And we're sustaining innovation by looking at science-based frameworks. We're supporting the technologies that are very needed, so satellites, so infrastructure, ICT, cloud services, and so on. Now, from the innovation, the sustained innovation, of course, improves the operation that are existing. So they are very instrumental, for example, for energy production. They're very instrumental for agriculture, which is the case of Med Gold. They're very instrumental for disaster risk reduction. If we have satellites, for example, we can monitor the state of the Earth. So technology is an instrument factor. And whenever we improve operation, it means that we're basically fueling a market. We're fueling a market for people that are demanding these services to improve what they're doing, but we're also fueling the market to make some portion of the society wealthier, richer, and even more sustainable. Market, though, cannot function without a signal. The signal is normally perceived as an economist as a price. We assign a price to something, we're giving a signal to the market. But the price is nothing but a product of how we create value and how much we create value. So the price, in the end, is a function of the business model that we are using. And the business model are also a signal to send to the market that some tools, some solutions are very much working and they are very much demanding. And that's how we come back to the sustained innovation process. So business models are very instrumental in understanding how we can keep on going with this virtuous cycle in a way. Next slide, please. That's where we are. Now, when we talk business, we're talking about a stepwise approach. This doesn't mean if you're creating a company, for example, with some partners of yours, you shouldn't go straight to, oh, let's talk about the business model, because maybe you do, but you need to do it in steps. So the first goal is to define the appropriate business model, testing, failing several times. Then to forecast the business sustainability, which is precisely what Federico was mentioning before. How can we actually make the business more sustainable, economically speaking? And third, reaching the target market. So before, in the first initial steps, you could have in mind, for example, to reach the insurers in agriculture. But then you find out that their market is saturated or is overflooded with other products, and you may change and turn into the for example, agents that are working in the agricultural market, so farmers. You can click now. The stepwise approach works in this way. First, we sketch the business model. You can click again. If we sketch the business model, it means that we're drafting the optimal business model, but then we need to test it, so to collect feedback with users. And the way we can do it, we'll see in a moment, is, for example, coming and going back and forth with the user and testing different operations and different features of your platform, of your ideas. You can click now. Once you test, you then try to image. Now, imagine that you found a business model which looks very much appropriate. You tested that business model with a couple of market segments, which means that you can image what the medium and long run future will look like. And this exercise is a very qualitative exercise. You imagine, for example, if the market is going towards this direction, is a sort of scenario analysis that you're making with your partners inside your HQ or your bedroom or your house, and you're basically trying to forecast how is the evolution of the service. You can click now. Whenever you do have the image step, so a qualitative step, you can quantitatively transfer this imagination into numbers. And to do that, you're writing the cost that you're bearing, the revenues that you're bearing, and you're basically designing a business plan, which is not the same of a business model, because the business plan is the document that we are using to collect all this quantitative information about the costs that you're bearing, the finances that you're receiving, the revenues that you're generating, and potentially also the grants and the collaboration that you're having. So the business plan is a document with numbers, but the business model is the way you create value. So the way you create value in the end is transferred through specific metrics that are falling within the business plan. And I'm going to send to Alessandro then a fake business plan, let's say a fake document that you can then fill, but there are also the formulas inside, so you can see how. Then, yeah, you can click both of them. When you reach this step, that you forecasted the costs and revenues, you can start knowing a bit better your customers. So you tested, you have an appropriate business model in mind. You made your homework by including several numbers, but then it's important to know even better your customers. So understanding what that persona that Federico was speaking about likes, needs, why, in what context, how often, and where. And this means that you're positioning yourself within a value chain. So everybody who says, we are the first service doing this and that, lies and knows that they lie. Because maybe there's something that is not precisely the same, but there's something somewhere that is doing something very similar. You need to start by thinking, I'm a genius, but not that much. I'm original, but not that much. Maybe I didn't copy anyone, but somebody had maybe my idea. So you start with this idea in mind, which means that you run a big due diligence of the markets that are existing, testing different keywords and different combinations. Imagine in the field of climate services, for example, if you Google climate services, you may find 0 climate services, because many, relatively few, are using the term climate services. Different is those who are using terms like adaptation consulting firms or climatech company, clean tech in the US is very popular, for example, to change the name of climate services into clean tech, climatech, clean tech. So they are at the intersection between technology and climate. Normally they are consulting firms, so you need to understand who is in this space and position yourself along the value chain. Next slide. Finally, we finalized this stepwise approach. The sketch thing, we already touched upon that. How do you sketch the optimal business model? There are several tools that you can use, practically speaking. You can definitely sketch it by drawing on a canvas the business model that you're using a framework that is guiding you. Two big frameworks are existing. The first one is the business model canvas, which I believe you already saw in one presentation. Then if you haven't, we can stop there, or we can touch upon it later. But the business model canvas is made of 9 building blocks, and these 9 building blocks are normally value proposition, which is very important, then the cost, then the revenues, key partners, key activities, key resources, customer relationships, and channels. Then there is the lean business model canvas that eliminates 4 blocks from the original business model canvas. And the new blocks are added. And these new blocks that are added are competitive advantage. So you're basically making explicit at the end of the day why you're better than the other, and unique value proposition. So you're basically explaining why your value proposition is not precisely like the other, but it's unique. The reason why the business model canvas is so used is because it's easy, it's understandable, it's translatable to every kind of business. Doesn't really matter if you are in the climate services realm or not. But the lean business model canvas is very useful if you're very much in a startup phase. So you don't really have a solution. Imagine in this case, for example, MedGold products, MedGold climate services are something that have been tested with research and development. So we're not anymore in the startup phase. But if you're starting very much from scratch, then you can use a lean business model canvas, which we are exploring in a couple of slides. Then there is the revised business model canvas, which is not necessarily an accepted one, but the reason why I put it here is because we created the revised business model canvas in Clara, and so we're doing a massive self-promotion. But the reason why it was very much working for climate services realm is because we focus on the value network, and we understood that the value network is very important in the co-production process. By value network, I mean everything that is around your firm or your product. So stakeholders, shareholders, potential users, interested partners. As Clara project, one of our value network major stakeholder was MedGold, for example, because we had a lot of interaction with these processes. And in the co-production phase, it's very important to understand who is doing what and how often you are communicating with them. Next slide, please. Move to the second phase. And the second phase is the test. Here you have an example of the lean business model canvas. So the second framework that I gave you. The unique value proposition is what you are starting with. So you're saying, what is your objective? What is your idea? This is coming from a real climate service that is already on the market. So, and it was done in January 2020. So last year. The unique value proposition for them was to open up, so to democratize technical and business relevant flood risk intelligence. So they were operating in the flood risk domain, and they wanted to open to a new market segment of people and agents and companies and stakeholders that didn't know anything about flood risk intelligence. And they wanted to do it using machine learning and AI and open data, in this case coming from C3S that you saw a minute ago. From the unique value proposition, you discuss with your partners about what is the solution. So this was our goal, to create basically a democratized, science-based framework for flood risk intelligence. But the solution means there is a modular, tailored service to estimate the direct and indirect economic losses. So it's a platform, the solution. It's something that is physically a platform. Why do we need this solution? To solve a problem. And the problem is, how can we protect people and assets while also preparing for the future? And the reason why this thing works is because Safer Places has an unfair advantage, so a competitive advantage compared to other stakeholders, which is a scientific knowledge and strong reputation in the field. They were coming from a consortia of, I don't know, several research centers and a couple of SMEs which were very strong in producing climate services. They wanted to interact with a specific customer service. So at first they started in this phase with both public and private actors, and then they turned into the private ones because they tested that the private were actually more appealing to them. And they wanted to communicate with this customer service by building an ecosystem of partners. So building a sort of strong interaction and continuous come and go. They also created a cost structure, and then they questioned how can we make money, which is not, by the way, an ancillary problem, is a core problem. You're strong at doing something, and why you may be the best at doing something in the market, generating revenues is pretty straightforward. In their cases, they wanted a platform, but with a hybrid revenue model. So on one hand, they are combining a license-based platform, so you pay X amount of money on January the 1st, and you access the platform for the whole year. And on the other, they wanted to create a usage-based consulting fee. So if you're coming to me as a customer and you want an ad hoc solution, I'm going to give you the ad hoc solution, and I'm going to charge you for that solution. The hybrid revenue model is very flexible because it allows you to basically go into more markets. But at the same time, I can tell you that it's very dangerous because you're not in the end placing yourself in one single block, but you're allowed to move and mix and match and change. So in the future, they will have to choose either for one or the second. Next slide, please. These are all phases where they're testing. So they created a lead business model, but they will test it. Once tested, we need to image. As we said, this is a qualitative exercise. And one of the tools that you can use, which is coming, by the way, from sociology and educational domains, is the Free Horizons framework. So it was adapted in Canada from an idea originally of McKinsey & Company. And it's very useful because it's a canvas on which you have 3 lines. Every line represents an horizon. So using this framework, you can project short and medium run future market-oriented climate services. You start with the first horizon, which is the dominant system, the status quo, the red line here. It's the present, the business as usual. What is happening now? What is happening now in the market for climate services, depending on the sector, sometimes climate services are not used. So the business as usual at the moment, suppose, is very low usage of climate services. As you can see, the business as usual is very strong at the beginning. It's very high. So the y-axis is a sort of prevalence of existence of a given scenario. It's very high, but it's going down over time because, as always, we are living in a dynamic and transformative society, and we're constantly evolving, especially in market-oriented features. Then we have the third horizon, so we're moving straight to the green line here. And the third horizon emerges as the long-term successor of the business as usual. So in the future, it's becoming the new business as usual. The second horizon instead is a pattern of transition. It's something that is used to move from the first business as usual, so for the current business as usual, to the future one. So from H1 to H3. Next slide, please. How can you use it practically? This framework, you start with your partners and the range of stakeholders. We did it as an exercise, as a focus group with many stakeholders. There were 50 people. You start with the H1 and you start describing and reflecting what the business as usual looks like. You're very honest about how things are going now. You are declaring exactly the list of factors that you see. And so if you do this exercise with a sort of focus group, so more than 2 people, you see that more things are emerging, that people are bringing economic features, social dynamics, stuff that are happening somewhere else. There are also legislation movements that are happening at the moment to boost the use of climate services. And you describe how climate services in your sector, for what concerns you and your market, are going. Next slide. Then you move straight to the horizon number 3. So you try to imagine what kind of future would you like to see. So if you have a climate service today, you are developing a climate service today, you may say, today I'm a developer. In 5 years' time, I want to be not the leader, but basically one of the leading climate services in my space. And to achieve this goal, I want to see X, Y, and Z. So I want to see that I have 10 customers, I speak with 2 municipalities, and I have, I don't know, my presence at the major international conferences and one successful story of an Horizon 2020 project, for example. So you're imagining your future in the time horizon that is more convenient for you, normally 3 years or 5 years. Next slide, please. Now, since we're not living as Snow White going around and we want to imagine dark futures, of course you want to go somewhere, and that's your dream or your goal, but what should you do in the meantime to achieve the new status quo? This is the transition phase, H2. So you're moving from the present to the future, and you come back to the transition. And there you start thinking about what should I really do to actually make the future that I'm imagining happening. By the way, this is an exercise that can be applied to every domain, in research and beyond research. So it's a very practical tool, but it's very useful also in focus group to actually understand what are the expectations of your clients, what are the expectations of your donors, what are the expectations of your team. Here in this phase, you're listing all the requirements that must happen in order to move from H1 to H3. Next slide, please. And now, since we want to be complete and not, again, very much blurry in line, what you have imagined must be transferred into tangible quantities. And unfortunately, apart from concrete things like apples and walls, we have numbers that are very, very useful. So here you need to translate every assumption that you made about the future into numbers. For example, if you want to be the leading climate service in the future, you need to have how much money of funding, 500K or 1 million or 2 billion. How much money do you need? So your financing needs are important, your costs are important, and based on the cost and the financing needs, then you will have the revenues projection. The tools that are used are many. Normally, people build it from scratch. That is what we did, but there are many tools that are very much available. The point is that this process is a necessary step. So if you want to apply, for example, for money to donors, you need to have the business plan, and you need to have a set of metrics that they can look at. So they need to understand that your assumptions are feasible. You cannot go in front of a donor and say, I need 1 million euro. For what? Without specifying. Because maybe they have it, but they will never give you that money without understanding why and what you're doing with that money. So there are useful tools. Again, they're very useful to check the coherence with what you have in mind in terms of imagination, so qualitatively speaking, and what you can achieve with the numbers that you're seeing. Then again, I'm sending the template so that you can circulate it. Next slide, please. And once you forecast, then you are in the process of knowing a bit better. So you created the optimal draft of the business model. You tested it. You tried to understand how, by using that business model, you can achieve your goals. You quantified how much resources do you need, how much resources will you make, and how much value you will create. So here you will need to understand for whom, because it's an important process that you need to do at every step that I mentioned before. But at this stage, it's very crucial. You need to understand if the customer, the persona that you identified in the sketch phase and in the test phase is actually the most appropriate customer that you can have. Is it really the one that can provide you with the best possible options? Are you really responding to the need of this customer? And by understanding who the customer is, you understand the market segment. For example, if you realize that your core market is, again, the financial sector, so the insurers or the funding companies, then it means that you're tackling only one market segment. You're not going to municipalities. And if you are, you're just wasting a lot of energies and time and effort. So you're asking yourself, who is actually using my service? Should I be small, like a niche service provider? Should I be big enough to cover everyone? And how much of my infrastructure would I need if I want to cover 100% of my target market segment? What kind of tools can you use here to know? Focus groups, surveys, questionnaires, phone calls, emails, ringing bells, which is not necessarily the most appropriate things to do now in COVID times, but who knows about the future. But in general, speaking to people a lot. Like you think, for example, that some questions are silly, they're not. You may find out that the reason why your customer doesn't use your service is because they don't like the color of the platform, which seems a stupid thing, but instead it's not. Or maybe you may find out that the person that is actually your customer is colorblind and you're not using a color blindness friendly palette, for example. So they don't understand the maps that you're providing. Next slide, please. And once you stop with the knowing your customer, you need to lobby very much. It's not true that companies are not lobbying. It's not true that companies are not pushing for change. And it's not true that change is the main driver for companies. Sometimes it's very much endogenous. So are companies creating change that is enabled by politics and the new political framework. So it's very important for a company to push for a legislation that is favorable to these services. And in the case of climate services, is very much important because imagine, for example, a country that is introducing an incentive to use climate services in agriculture. If users are actually doing it, it means that they will hopefully perceive less losses, which is a saved cost for the country and for the municipalities and the state as a whole, because nobody needs at that point any protection schemes and any buffer schemes. So legislation is important to provide the incentives to user to use these services. And in this case, we're not talking about a dark matter thing. We're talking about something that is actually a very useful one from the economic, environmental, and social point of view. So here it's important for you to explore the existing policy frameworks in the continent, in the country, in the market that you are targeting, and understanding what are the legislation gaps. If needed, you need to lobby to make it happen. How to be credible when you do it, with only one rule, which is quality assurance. Nobody wants a climate service that is, I don't know, an imprecise one or not a respected one. That's the reason why, for example, Copernicus Climate Change Services pays a lot of attention to quality assurance, to provide information which are double, triple checked, because being reliable with your customer is the golden rule for to create a climate service that is successful. Next slide, please. I think the next slide is the last one. So this is my content. I'm going to share the template. Of course, one thing is speaking about the different steps to make a climate service working, and the other thing is doing all these steps. It's a long process, iterative process, dynamic process. This is a stepwise approach, yes, the one that I'm presenting, but this doesn't mean that you should follow the steps in this order. It means that you need to combine and doing a sort of mix and match of these steps at every stage in time. If you feel, for example, when you are at stage 3, that the business model is not optimal yet, you come back to step 1 and you sketch again using the existing framework. I thank you for your attention. I stop here. And if you have any question, I'm going to be connected. Oh God, I don't hear any voice, so I don't know if I was actually disconnected.
Thank you. No. Thank you very much, Francesca. No, I was muted. Sorry, I was muted. And thank you very much, Francesca, for your presentation. And I think that this presentation could fit very well in this living dialogue, especially in this final phase of the living lab. As usual, we are just a little bit late, so I think that there is time just for one quick question from the audience, and however, you'll have the contact of Francesca in case of further question to be addressed. So time for one question, if any, sure. Please, Luigi. No, please, Luigi and Tony. Okay, very quickly, but thank you.
Okay,
Luigi.
Tony, you go first.
Okay, thanks a lot. Thanks, Francesca, for this presentation. I was wondering, so in this whole process, I imagine you want to keep your business idea fairly secret because you don't want anyone to steal it. But at the same time, you have to test it on potential customers. How do you do that?
Okay, in climate services is becoming a bit impossible to actually keep your idea secret, especially if you're coming from a European project, because we're actually required by mandate to share everything and to be completely public. Two things are impossible basically to copy. Are very difficult to copy. The codes behind, so the routines, people must be super skilled, and yeah, you can publish your paper with your methodology, for example, that is underlying the climate service, but this doesn't mean necessarily that people can copy you. And the network that you have is something that is not replicable at all. So in terms of protecting the sort of IPR, say, it's very important to keep the core of what you're doing, maybe not secret, but to be shy about sharing everything. But testing can be done in small pilot groups, selected group of people, beta testers. Beta testers can sign an NDA, so they can actually sign a document saying they cannot share, they shouldn't share, and they will not do it. It's important to keep alive your relationship with other projects, and in general, will also to make questions to the others. When I started doing the first due diligence, for example, for a project, I started asking for the business plans of the different climate services because I was naive and I was living in my own world, because nobody will give you the business plan. They will if you are a donor, but the business plan is the most important document. So no, don't share the business plan. By sharing something like the value proposition, well, if I tell you I want to democratize the science-based, the risk intelligence, how can you really understand if my flood risk intelligence is a platform with C3S data? It's very difficult. So in terms of protecting, it's important. Don't talk too much. That's my advice, but this doesn't mean that you should not test. That's important. Test with beta tester, your friends. At the beginning, it's very important your family too. If your grandma understands, it means that the service is fabulously written and understandable.
Thank you, Francesca. Luigi, time for a very quick question.
Okay, sorry. Thanks, Francesca, for the nice presentation and also for your partnership along the common path of the two projects. That was very nice to have because your perspective is different from you, and your background is actually something that we don't have in our consortium. So I wanted to ask you if you found something that is peculiar to climate services with respect to other services that you develop, and something that is particularly hard to do when you develop a climate service versus whatever kind of service you go about developing in your experience. Because at Clara, I remember you had a range of climate services that were developed, not only in agriculture, right?
No, we were operating in 7 sectors. I think that the most challenging thing, most promising stuff was energy. But in energy is also, the process is very long. People want to test for 5 years because we're talking about a huge amount of money. So they don't want to lose anything, not a single penny based on probability-based seasonal forecast, for example. We were seasonal forecast based again, so maybe climate projections are less doable for some sectors. The only thing that I find as a difference is not within the climate services, but between climate services and other services, which is something that the literature should definitely explore. If you're going, for example, to health services or to insurance services, climate is more difficult because people should introduce within their own mind and within their own mental framework a variable that normally is neglected or was neglected. And if you're going to a farmer, they will tell you, oh, no, sorry, I've always done it this way, planting the same crop for the past 25 years. And of course, he knows his job. So it's just yeah, well, and you don't know. And if you're going to somebody else, it's the same. But I think that the climate services realm is mostly the most promising. It's probably the most promising one in the next 5 years. And I'm pretty sure that I will have an app, seasonal forecast app in my phone, like in 2 years' time. So it's difficult, but it's so promising that in the end it will go.
Grazie, Francesca. Thank you very much.
Thank you very much. And now, before the comfort break, a few minutes for Marta. Marta Suarez, the floor is yours for some relevant information.
Thanks. And thanks for the speakers as well. Really interesting talks this morning. We just wanted to ask you for 5 minutes of your attention. It's just within the Living Lab, and this is something we did in a previous session as well. We did put together a feedback form to get your feedback on the run of the Living Lab and kind of your experience from it. So this is the time to do it again. So I'm putting it in the chat. That's a link to a very quick feedback form, and we would really love if you could take 2 or 3 minutes to fill it in now. I should say as well that the feedback form is anonymous, so feel free to provide your views on how we've run the Living Lab and how we could improve it. But we would ask you to do this before we go into the break, if that's okay.
Thank you very
Depends
much.
on how urgent the break is.
Yes.
Yeah, of course. You can also, sorry, yes. If you really need the loo, you can go first. But yeah, but I mean, kind of as before we go into the presentations from the groups. That's
okay. Thank you very much, Marta. So we can reconvene in 10 minutes, so at 12:35 sharp. And the first presentation will be from the durum wheat problem. So Alessandro, please be ready for your presentation, and we'll reconvene in 8 minutes starting right now. And please fill the feedback form. Thank you, and we'll reconvene soon. dear all, I think that we could reconvene. And so I would ask to Alessandro to be ready to present. And but before starting, one consideration from the from the organization team, and let me just share my screen. So, considering the the very impressive level reached by all the teams in this exercise of the Met Gold Living Lab, we have decided to offer a sort of award to the three teams, and the idea is that Met Gold could offer open access fee for up 3 peer-reviewed papers based on the three problems. So we would encourage you all to to write a paper on the problem that you have touched, or even on the network established during the Living Lab. The deadline for publication is next May, is May 2022, with the end of the project. Moreover, we are also thinking to write a short summary of this event for BAMS, Bulletin of American Meteorological Society, that often host some summary of this kind of event. And for this summary, you'll be involved somehow. We have just to understand better the guidelines for this kind of presentation, and so we'll keep in touch also for this other paper to be published on BAMS. So we would encourage you all to keep working on your problem and your exercise, because we think that the team are in the right track to write something, also in collaboration for sure with problem holders if they are available. But I think that something quite appealing and interesting that could be obtained from your work. So I think that we could now leave the floor to Alessandro and to the problem regarding the durum wheat. And first of all, Alessandro, let me know if you are available to put your presentation in the web repository. Thank you very much. I stop sharing my screen, and let me know if you want to share by yourself or not.
Okay. Good morning, everybody. Thank you very much, Alessandro. Yes, can I share on my own the screen? Okay. Can you see it?
Not so. Okay. Yes. Great.
Okay. Yes, of course I can share the presentation wherever you want.
So put your presentation at the end in the chat, in the Amazon Chime chat.
Of course.
Okay.
Of
Thank
course,
you. The floor is yours.
Okay. The name of my mini project is optimizing the use of nitrogen fertilizer in durum wheat fields, combining crop models and seasonal forecast. As I already showed last week, what's the problem? The main problem explained by Horta, Matteo, in his presentation, it's about when and how much fertilizer to apply in durum wheat fields, especially nitrogen demand fertilizer. And what are the main difficulties? Difficulties are connected to meteorological condition, physiological necessities, and cost-related difficulties. My idea was I proposed to use a crop model together with seasonal forecast, especially particularly the crop model I used is Monica. Monica was developed by ZALF in Germany, a research center in Germany. It's a mechanistic process-based model on a daily basis, dynamic on a daily basis, and one-dimensional, meaning that it simulates a 1 meter square per 2 meter depth plot. Of course, as usual crop models, input data are needed for the model to run are weather data, soil and site data, crop data, and management data. Altogether, Monica is able to simulate and describe the transport and the turnover of carbon, nitrogen, and water in this ecosystem, agroecosystem. And you can obtain many different variables, output variables from the model. I used the seasonal forecast downloaded by Copernicus Climate Change Service. In particular, I used 1 year, not even 1 year, but 8 months seasonal forecast, starting from October 2019 to May 2020. What did I need for the model? I need those variables: average temperature at 2 meter high, minimum and maximum temperature in the last 24 hours, wind speed at 10 meters height, the global radiation net, the surface net global radiation downwards coming from the sun, total precipitation, and relative humidity. This is the time series of rainfall, total rainfall, and average temperature in red and in blue. And of course, the area I highlighted in red is the area that contained the experimental plot of Horta in close to Ravenna. I averaged all this data, and I took the average of the grid, of the 1 degree grid, and these are the time series I inserted. I fed it into the model. Then I run two crop rotations, two different crop rotation with Monica. The first one is a pure sowing and harvesting. Sowing on the 7th October, 220 seed per meter square of durum wheat. Harvesting on the 2nd of May. Unfortunately, since my seasonal forecast ended on the 5th of May, I couldn't wait until the full maturity of the grain and of the durum wheat. The second crop rotation, in the second crop rotation, I added mineral fertilization at the beginning before sowing, and on the 7th of February, during the heading of the durum wheat. You can see on the two graphs, on the left the crop rotation 1, and on the right the crop rotation, the second crop rotation. You can see the plot of the yield obtained in the simulations, together with the phenological phases of the plant. Of course, fertilizing durum wheat allows to obtain a higher yield. We can see that at the end of the simulation, the yield is about 7,000 kilos of dry matter per hectare, instead of the 4,000 kilos per hectare of the simulation without fertilization. What did I do this for? I intended to understand what are the nitrogen response, the response of the plant to nitrogen stress without fertilizing and with fertilization. About this, I would like to explain you briefly how nitrogen stress is calculated in Monica. Of course, it depends on photosynthesis. Photosynthesis is described with the Farquhar approach. And when nitrogen is missing, when nitrogen is below a certain critical threshold, plant-specific, the amount of assimilation from CO2 starts to decrease by a factor called, that is the Xn, called the reduction factor of nitrogen deficiency. And this is the curve of how the reduction factor goes as a function of the nitrogen concentration in plant tissues. This is my nitrogen analysis. On the left, we have the plots for crop rotation 1. so without fertilization. On the right, we have the fertilization crop rotation. You can see that without fertilization, on the 21st of December, the nitrogen reduction factor start to decrease. This means that the plant is suffering from nitrogen deficiency. You can also see at the bottom of the page the same graph, the nitrogen reduction factor as a function of time divided by phenological stages. Of course, heading and the fourth and the fifth phenological stage are the more sensitive to nitrogen stress. What happened when we fertilize the experimental plot? You can see it on the right. Fertilization is applied on the 7th of February, and we can see that the nitrogen reduction factor increased again, giving less problems to the plant, and of course producing much more grains and yield. Therefore, the nitrogen reduction factor goes below 0.8, that is a threshold, common threshold, only on the 15th of April. More variables can be taken out of the simulation. For example, the nitrogen content in the grains. Of course, crop rotation 1 has a lower value than crop rotation 2. We can also look for above ground biomass nitrogen content, and you can see in the 4th phenological stage the effect of the fertilization. As for the nitrogen leaching, of course, more variables can be studied from this model. The first result has been obtained by simulation of multiple scenarios. So I understood what is the most probable nitrogen stress time interval of the season. Of course, more developments could be made, more simulation could be run to determine all the results. All the expected results. This is all. Thank you for your time.
Thank you very much, Alessandro. Thank you.
Thank you. And I don't know, Massi, if you as mentor, if you have some comments on the work done by Alessandro.
Oh, yes, please. I have to say that, well, the first key element is that Alessandro essentially developed all his work by himself. I just gave him just a few help in some specific steps, but everything was done with the contribution of Matteo and Valentina from Horta that supported Alessandro very well, and he did everything by its own. And I think that he was really able to describe a full potential strategy to catch the key points for the specific problem, and I'm really happy for his work, and I do believe that Alessandro touched with very well the complex dimension of the problem of extracting salient information from a so complex and articulated chain of models. And so I think that he was also happy to do that. Thank you very much, Alessandro. You did a good job.
Thank you, Massi. Thank you. Of course, I'm sorry if I didn't have that much time to run more simulations. And of course, I did what I could in 1 week. Unfortunately, I had only this time to work on it. But I'm happy to work on more on it. I have no problems also collaborating with Horta, with people from Horta. It's definitely an interest matter to study.
Yes, thank you, Alessandro. As Matteo today cannot be here, we have here Pierluigi Merigi from Horta, which is an expert in durum wheat. And just a few words from my point of view. I think you did a good job by individuating, selecting a very interesting model which fits the problem we gave you, and just to show us some result that seems interesting for the application of this model in this towards what was the problem. I think you did not use you used observed weather data. Is it right? Or were these weather data forecasts?
No, I used forecast. I didn't use observed data. Of course, I would like to validate the model. I asked Matteo for collected data in your experimental plot in Ravenna to validate the model, but I couldn't download, because the problem is that Copernicus forecasts are only 8 months long, so I couldn't simulate until June, until the actual durum wheat harvesting date. But of course, with observed values, time series from precipitation and all the meteorological data the model needs, I could validate the model and understand if
yes, I know
results
the
are
seasonal forecasts are have a few. It's do not cover the whole durum wheat cycle, so I understand why you did not simulate it in the end. But anyway, I think it was a very interesting way to proceed. And if you're interested, I think we can be available for further collaboration in this work.
Thank you. Thank you very much.
Okay, I don't know if there are any other feedback and comment, even from the rest of the audience, from the other group. I have just one suggestion. In this case, when the seasonal forecast is not long enough, one possible option is to use for the remaining months acclimatology, for instance, or acclimatology, or a sort of random chosen mean of the months missing from the past, or something like this. There are several techniques to merge climate prediction with observation for this kind of situation. That is just one suggestion that could be used. And thank you very much, Alessandro. Please send us your presentation. And I would leave immediately the floor to the second group, the red team, for the olive oil, because I know that Marta could have other meeting soon. So please, red team, the floor is yours. Please simply take over the screen and present your work. Thank you very much.
Thanks, Tony. Can you all see the screen, or is it just me?
Can you see the screen, or is it black?
No, so far is only is black.
Okay, just a second. My computer needs a little bit. Okay.
You want me to try, Tony? Because you did send a presentation, didn't you?
Okay. It just took a little bit. Does it work now?
Okay, yeah, it works now.
Perfect. Yes. Thanks, Tony.
Thank you.
So we are presenting the key results that we obtained by working on the project for DCOP, our stakeholder, and by brainstorming together on the development and the proposal for the development of a climate service to provide future projections on climate risk to olive oil production. In the following slide, we are giving a brief introduction to the state of development of olive oil production, both in the Mediterranean region and worldwide. And we can see how production is extended all over the Mediterranean region, but Spain is the main producer in the area, although other key areas are emerging worldwide, for example, in the US, China, Australia, and Chile, among other countries, demonstrating the economic impacts that this may have on Spanish olive oil exportation, for example. Therefore, in the following slide, to comply with Javier's requests, we aim to understand what will be the climate impacts in the mid-term and long-term future, primarily in Andalusia, where DCOP's work is focused, and if this will drive producers in the area to stop producing olive oil, but also compare with other results in other areas in the Mediterranean region to understand if these new areas will become suitable for olive oil production, and to understand the opportunities for DCOP competitiveness in the future, for example, to export products worldwide. In the next slide, we propose the development of a new tool to complement the already available dashboard to end users, which will focus on future temperature and precipitation projections, combined with an agricultural model, which includes other key parameters such as soil quality and solar radiation and relative humidity, to evaluate olive oil production and define the most suitable and unsuitable areas according to results in Andalusia, Spain, and the Mediterranean region. The next slide shows the key steps that we define to build a user-friendly climate service. And as you can see, this constitutes a back and forth process rather than linear process. So starting from primarily research and combined with understanding of users' needs and validation of the tool. So in step one, in the next slide, with regards to background information, we understand how olive oil production is constrained by extreme warm and cold temperatures, key phenological phases, and how, while this crop is relatively drought tolerant, is primarily rain-fed, and therefore reduced future frequency and intensity of precipitation may impact its performance in the future. In the next slide, the consequences would be the shift in production to more suitable areas, primarily in northern areas in the European Union, within the same countries, and as well as economic impacts to already producing areas, which will need to readapt, and this will require adaptation investments such as on irrigation systems or crops relocation. In the next slide, for step two, we understand how background information clearly needs to be combined with a thorough understanding of end users' needs. In this case, primary and secondary agricultural cooperatives in Andalusia. And this can be achieved through the process of co-production of climate services, through consistent and participatory engagement of end users throughout the whole process. So our idea is to conduct interviews and surveys to deeply understand this information, so what information is already available and what further information is needed, and how the information will be used, and what is the preferred format and ICT to develop the tool that will integrate this information.
On the next few slides, we'll present a few preliminary results. So some of the indicators that Javier gave us were, for example, spring temperatures, which create heat stress if they exceed a certain threshold. And historically, in Andalusia, which is the region we're looking at for the next few slides, Andalusia in southern Spain is the largest olive producer in Spain, the largest olive oil producing region in Spain. Historically, spring temperatures were exceeded only 0 to 4 days in the region, and our projections, climate projections from the Met Gold dashboard estimate that mid-century and late century, the exceedance could be between 5 and 16 days over spring for mid-century and 7 to 22 days for late century. That means, well, in the past, we had one exceedance day for about every 2 weeks at maximum. In the future, it could be up to 1 in 4 days or 1 in 3 days, depending on the climate scenario and mid or late century. That means there will be more heat stress on olive trees. There will be reduced flowering and reduced growth in olives, and with that, reduced yield, which has economic impacts for olive farmers and DECOP as a cooperative. We also have shorter recovery times between extreme days. So if 1 in 4 days is extreme, you only is exceeding 32 degrees, you only have 3 days for trees to recover from that, which could increase heat stress on them. We also looked at winter rainfall. Winter rainfall is optimal at around 450 millimeters between October and May. If it's more than that, olive production will increase. It will be good for olive production. If it's less than that, there will be a loss in olive production. But 450 millimeters is a good threshold, according to Javier. Historically, from 1971 to 2000, that was exceeded in about 35% of the region. We have a map here that shows winter precipitation, and it increases from west to east. From east to west. And yeah, 35% of the region, 450 millimeters was exceeded. For the high warming scenario, which is the likely one that we're on track right now, mid-century, it will be exceeded in only 10% of the region because of a decrease in overall rainfall. And by the end of the century, it won't be exceeded anywhere in the region as rainfall will be below 450 millimeters. For a moderate warming scenario, it will be 19% by mid-century and 25% by late century because of a projected increase in rainfall for moderate warming. That means there will be a loss in winter rainfall for moderate warming of 236,000 liters per hectare, or about 6% in precipitation. For high warming, 313,000 liters per hectare. That means that already by mid-century, there will be a significant increase in irrigation costs and irrigation needs. And for anyone that lives in the region knows irrigation and water is already a very difficult topic, and there's already water limitations. So this will be hard to realize. On the other hand, there'll be more control of the quote-unquote rainfall, as irrigation allows for better timing of the watering of trees. Again, by late century, we will have less irrigation needs for moderate warming, but a significant increase for high warming scenario, with about over 20% loss in winter rainfall. In summary, we project to have excess spring heat, which reduces flowering and reduce winter rainfall, which of yield. additional features for the future, we propose to use better homogenized data for to model the relationship between climate data and olive production. We had difficulty finding data that matched, so both from the observational period, the last 50 years, as well as the future. That was a limitation we found on the dashboard, and generally in terms of data availability across the EU. Another climate variable that's important when we look at future areas where olive trees could be grown is annual rainfall, which optimally would be between 600 and 800 millimeters. And what we found historically, that Andalusia and Spain in general is tending towards getting too dry, and in the future this will be accelerated. So this is a high warming scenario for mid-century, 2021 to 2050, and we see that the Mediterranean or the Iberian Peninsula, especially Andalusia, will increasingly become too dry, as well as Morocco and Northern Africa, Algeria and Tunisia, which are also large olive producers. We also see a drying in southeastern Europe across the Czech Republic, Slovakia, Romania, but there it means that areas will become more suitable for olive production because they get drier into the suitable rainfall range for olive trees. Our future proposed steps would be to consolidate, to coordinate with our stakeholders at DICOP to see what their specific needs are. The questions they gave us were fairly general, so we'd be interested to know more about their process and develop a more tailored climate service to answer or to assess their future decision needs. Develop a service, consult back with them to gain more feedback. And what we just presented was merely sort of a first step into this, and kind of a stepping stone for more advanced services in the future, given more time and probably funding. So something that we would propose is integrate multiple climate variables, so not just temperature, not just rainfall, annual rainfall, but also things like the variability from year to year to estimate the severity of drought or wet years, as well as cool and warm temperatures. Then use additional maps to show the past to future change in current production areas, as well as the production overall and yield of olives. Use additional factors, non-climate factors like soil and terrain, to estimate where future areas, to estimate suitable future areas based on these conditions. And also assess the competition with other crops that are grown in future areas that olive production would be suitable for. And with that, we're happy to take any questions. Thanks.
Thanks a lot, Tony, and thanks a lot to all the team. I don't know if Marta is meant to want to add something on that.
Yeah, I can start. Thanks for the presentation. It was, besides beautiful, was very effective. I thought it was very clear, and you obviously thought very carefully about the different steps you want to integrate. You know, considering that you had a very broad question that we were trying to address during the Living Lab, but the fact that you recognize, you know, the conceptual steps that you would take if you were to do this, you know, moving forward. So that was great. And I love the whole canvas thing. Is really It makes the presentations really nice. So that's nice as well. In terms of
credit for that goes to Andrea.
I know, but it's good. I learned. I'm going to start using it from now on because I think it makes a really impressive presentation, and it's very pleasant to see. I just have one question in relation to what you're proposing. About this new tool that you would consider. At the beginning of the presentation, you mentioned about this kind of including additional information into this agriculture model and kind of thinking ahead, right, in terms of long-term climate change projections. And I think you then alluded back to it again towards the end, Tony, in terms of including these additional factors that are not necessarily climate variables. And I'm just wondering if you guys thought through in terms of how where you would go and find that kind of information. So things like soil, information on soil, terrain, solar radiation, soil moisture. Particularly in terms of, I'm considering in terms of where you would get this kind of information for the long term, right? Because that's kind of the timescales you guys are considering here. So I'm wondering if you thought a bit about that and how you would go about finding that kind of information.
It's difficult. I found it difficult to find climate information in general for Europe. I don't work in that area quite so much, but climate models, global climate models, provide soil moisture projections based on projection of temperature and rainfall. So there's added uncertainty in this kind of derived variable. I'm not sure where to get soil type information. So if it's a sandy soil, loamy, clay soil, but I would imagine if this data was available, it would be it would add significant value to our projections because that kind of data doesn't really change as much over time. A sandy soil will not turn into a clay, or a loam will not turn into a sand. So that won't change much. Exposition, solar radiation is also something we can model very well. So if it's a southern slope or a northern slope, depends a lot on the kind of solar radiation that we get, and that's not going to change because the terrain will stay the same. I know there's land cover data sets in the US that are available to the public through USGS and NASA. I would start there and ask experts if there's an equivalent in Europe, but that's how I would start. I don't. Maybe someone else can comment as well.
Mm-hmm. No, I was just trying to understand, and you're right. I mean, a lot of the informations you guys alluded to are not things that actually change drastically over time, but are important factors when you're analyzing and trying to have a clear understanding of what is the trend in terms of all of our production. So I mean, in terms of the data sets, I do know they exist, but perhaps some of my colleagues will know a bit better where we could go and find these kind of information at European level. Maybe Luigi know about this, or even Alessandro. Luigi, do you know?
For the data sets to explore?
Mm-hmm.
Well, one, I mentioned different from climate, because I mentioned earlier like regional climate data set that to me is very interesting because it's very, very new. But when you move away from climate, it becomes harder, to find consistent data sets with good coverage. A lot of work has been done for soil to make a map that covers the whole world. And there's I don't have, I can't recall the URL, but there's also efforts that made use of artificial intelligence tools to predict soil information at different depth in the soil. I found them very nice because they the coverage and the of soil data, it has been a long-standing problem, and the data sets are very very different in detail and parameters that they show. So that these people, it's called Open Geospatial Consortium. They made a big effort to kind of make it consistent and very high resolution with tools that hadn't been used before in soil science. And this is something I will have to find the reference for, and I will share.
Mm-hmm. Yeah.
Hopefully before the meeting ends. And that there's a lot of data. FAO, which we have used in the hands-on sessions for agricultural statistics, and there's a lot of data there, but it's kind of unstructured. You have to go there, find out the level of detail, because the different administrative level at which they collect data varies across the globe. So you have to make your own decisions what to use, and then you have to give it a geographical reference if you want to use it on top of other layers and make, including the climate one. Yeah. So there's a bunch of problems that you have to address when you move away from standard climate data sets, and that makes climate services particularly interesting and challenging to develop, as we have seen during the project.
Yeah, thanks, Luigi. I should say, I know more in terms of the UK action, and I know that I think also it's a scale issue here as well. One thing is working at local, national level, but then when you extrapolate and you kind of open up and start looking at regions like Europe, you need to then be quite creative in trying to understand where you can get this kind of information. I'm assuming the European Commission will probably have some information on that, but perhaps you might be also working with national databases as well. So, for example, in the UK, I know that you have land cover layers of information that are available through the ordnance survey maps and things like that. But for example, at European level as well, the other thing I wanted to raise as well, and this goes beyond Europe as well, there's a lot of efforts being done at the moment in terms of satellite data as well, which kind of probably gives you access to a lot of some of these kind of, land coverage, for example, kind of analysis. I don't know the ins and outs of it. I do not work in that area, but I do know that there's been a huge effort towards start using satellite data, things like the Sentinel-2 and things like that in Europe, that can actually open up that, access to other types of layers of information. And I just wanted to finish my comment saying that, and I think Luigi already alluded to it, is the challenges of integrating different kinds of data sets when we go beyond climate data. And even within climate data sets, to be fair, there are also challenges of integration and how to operationalize a service using different data sets from different sources. But this challenge increases when you start trying to bring other types of data sets, not only in terms of type of data, so if it's geographical, if it's statistical, and things like that, which needs to, it requires levels of conversion and also decisions, trade-offs in terms of what to include, what to exclude. The units of analysis as well are different often. So there are different aspects that one needs to consider when trying to integrate different data sets into the climate service. But I'll leave it there.
Well, and I guess one thing we didn't even talk about was the whole human component. Will people be willing to switch from whatever crop they grew to olives just because it's more suitable from a climate perspective? So that whole social component is something that we didn't even address, but it also makes a big difference, I imagine.
Yeah, you mean in terms of actually having the knowledge of what might happen, but yet be constrained by all sorts of different conditions that might or may not allow you to make that switch, right? that kind of
exactly
adaptive capacity, right,
to
respond to that challenge,
right
that is coming. Yeah, definitely. I mean, that's where that's the linkage as well between the climate service and the adaptation domain, right? Kind of the transition, which is we do have the information, so we might get to a point where we get a clear trajectory or what might happen, but then there's the factors and the conditions on the ground that might affect people, organizations, communities to be able to adapt or not to those changes that are coming. But that's where the two domains kind of link, that transition from, really tailored, useful, usable information into the realm of adaptive capacity, the constraints, which might be personal, might be organizational, might be, all sorts of different barriers and enablers that might allow them to adapt to that reality or not. But yeah, really interesting. That's another living lab on that side of things as well. Thank you. Well done on the presentation. Very good work.
Thank you very much.
Thanks.
Marta,
thanks to the whole group.
I don't know if Javier, do you want to add some quick word for the groups, or you have already say everything last time? Please, Javier.
Yes. Hello. Can you hear me?
Yeah. Yes.
Okay. Yes. Well, I would like to thank you very much for the presentation, for your dedication and work and emails too in these weeks. In summary, for you interesting in the olive crop and in the olive sector, because for this sector it is very important to continue to advance and implement, or at least to try a new tool that allow us to advance in the knowledge and sustainability of this crop. I believe the approach from the READ team is very or quite correct and valid, because even we are not clear about the way to follow in terms of the long-term projection. And thank you to MedGoal project and the Living Lab. We are starting to think about how to use the climate service. Also, I think the challenge of the olive sector was very open with a lot of information, data, and you have been able to imagine or visualize a very well defined climate survey, and for that I congratulate you. I take note about two points of the presentation. The first is the design of the different steps to develop this climate service, and I see is or I believe this design of the different steps seem to be in similar direction to MedGoal, and I believe it was worked quite good in the medical project. Obviously, it was very complex and hard, but I believe MedGoal has reached to a better knowledge in the olive sector, and this structure of the climate survey by the red team, following this line, and I think you are in the correct way, in my opinion, from a point of view. And the other point in the step 3, in the result regarding the precipitation and temperature, I see. I don't remember in the slide, no, but I see some area of Andalusia in the future, the precipitation will be above 500 millimeter, and I see in the map it could correspond to the mountain system or the system of Andalusia. I mean, as you saw in the last slide of the next step, I believe, as you, it's necessary check the slope of the area, because in a mountain very big, the olive can be grow. So I mean, in the next step, you saw in the presentation, you have in mind this type of issue, and this is a very good point. And that's all from my side. Thank you very much, and congratulations for your work. Thank you.
Thank you very much. Thank you very much, Javier. And for the people who could be interested, there is also a very interesting mail exchange in the chat about the possible data set. And thank you very much again, Javier, and to all the RED team for this very impressive work. And so, just to last but not least, I would like to pass the witness and leave the floor to the sorry, to the Felicidades team, and they work very effectively on the wine problem, and we already have the feedback from Antonio. But so please, team, the floor is yours. I don't know if you want to share the screen, or if you prefer that I'll present the slide for you. Let me know.
I can share the screen.
Great. Go ahead.
Can you see the presentation?
Not yet.
Loading.
Now it seems to work.
Perfect. So, felicidades to everyone. Cheers. Our team that you see listed here work on the problem that the Sogrape group issued us about what could be a possible fair fee to ask for to the farmer for a seasonal forecast services. We choose to deal with this problem, divided the problem in 3 steps. The first step was the evaluation of seasonal forecast performance, and in particular heat rate. After that, we performed a cost and benefit analysis to evaluate the protective action benefit. And the last step was to try to look at the problem from an ecosystemic approach, in order to take into account other aspects besides of climate services and cost for farmer. Our problem was specific for the infection disease of downy meal, powdery meal, and the problem with sunburn when these two infections can be treated by trimming the branches. So for the first part, we ask ourselves how good the seasonal forecasts are. We use the dashboard and we choose to focus on these three indices selected according to the suggestion of Antonio from Sogrape. And we try to compute the heat rate for this scenario. A seasonal wetter than normal, so we look at the heat rate of spring rain, and a seasonal warmer than normal, and so we look at the growing season temperature and the SU35, that is a number of days that exceed a certain threshold. Heat rate means how many times the seasonal get it right. So if the seasonal forecast get it right. So we look at the data between the 1993 and the 2020, and the take-home message is that the data available are quite good. The performance are good, especially when we look at the last part of the season. And the seasonal forecast in this case, according to this verification metric, are a reliable tool for farmers, and they can help them to plan in advance the season. That can be a helpful tool for farmers in order to have a better planning of the activities. The second part will be a cost and benefit analysis, and I will give the floor to Christine that will explain us better this part. Thank you.
So as I mentioned last time, the cost of inaction for fungal diseases is what I wanted to know, so I could see how much a farmer has it in the end. So I looked at four sizes of farms: 1 hectare, 5, 10, and 160. And on a 1 hectare farm, if you have a good yield, you make approximately 3,000 euros. However,
Sorry, my laptop is a little hot. Sorry.
But they can lose up to 1,000 euros due to downy mildew, and sunburn loss can be around 600 euros. So from your 3,000 euros. So this is the amount of money we're talking about generally. Next slide, please. And according to Antonio, on an average year, you would have 4 sprays of downy mildew. So I'm looking at specifically at a 1 hectare farm and determining that I have 3 types of farmers or personas, as I learned today. I have the reactive farmer who buys the spraying spontaneously. I have a prepared farmer that maybe, knowing on average you have 4 sprays, has already purchased 2 and will buy what he needs or she needs accordingly in the season. And then I have a proactive farmer that it does exactly what your seasonal forecast says. It says, okay, you can buy 4 sprays, and I trust the seasonal forecast entirely. And I think the key part is like, how much money are you trying to save? The prepared farmer saves between 130 to 200 euros. And the proactive farmer can save upwards of 260 euros on an average year. And if you had 100% hit rate, a proactive farmer, depending if you had a dry year of 1 spray or a very, very wet year of 7 sprays, can save between 65 and 460 euros. So realistically, you're somewhere in the middle of that. So I did this table for other size farms. If you go to the next slide, please. Now I imagine that you have a wet year. So you're talking, because this is where you're going to make your money from your seasonal forecast, in this case of the downy mildew, and if you wanted to hire some extra labor costs. So what I really want to show you is that you can lose money if you have the wrong seasonal forecast. So it's good that you save money, but if you had forecasted a false wet year, this farmer can still lose money. And so that's the takeaway message at this point, that he can or she could lose about 150, 160 euros. Next slide, please. So what I really wanted to do is just say, okay, if I have to determine the fee for a seasonal forecast that is 90%, 70%, or 50% correct in the farmer's perspective, which is the hit rate, what is an acceptable fee? So on average, if you had a 1 hectare farm with a forecast of either a hot or wet season, your savings range for 1 to 10 sprays, these are very extremes, is going to be 175 to 768 euros if you are a reactive farmer. But on average, you're probably going to save around 406 euros, 400 euros. And I just imagined it was myself, and I said, okay, this is the maximum you can save. And I thought, oh, well, I'm not going to pay 400 euros for a service. I'll pay 10%. And then I scaled that 10% of that savings, 40 euros, according to 90%, 70, or 50%. And if you look at what Laura presented in terms of hit rate, if you're really doing the forecast to buy the Downy product, which you need to know ahead of time, then your skill is still around 30%, 33% for the spring rain, but you're better on the temperature. So I would say you're really, if you were to sell the service today, you should aim for more of a 50% hit rate. So I would guesstimate 20 euros per year. Go to the next slide, please. And Alessandro said that to maintain this dashboard, we need about 12,000 euros per year, and currently there are only 100 users. But as we want to increase the number of users, as Antonio showed me, he said, here's a distribution of number of farm according to size. This is the number of holdings there are, number of farms there are. And if I multiplied everything by 20 euros per year, you could, on this very tiny, tiny farms alone, you'll make 162,000 euros. So I'm thinking it's okay, we can cover the costs of the 12,000 euros of the dashboard. But of course, you have to scale up this support. Let's pretend only half the number of holdings choose to pay the 20 euros. That's still over 10,000 users. So you're still safe in terms of maintenance fees. So what I wanted to say is that the number of small farmers can support the increased cost of a dashboard, or this dashboard alone. Next slide, please. Okay, and this was to show that, of course, there's so many more elements that can influence the cost of grapes and whether or not this is a valuable tool, see it land use, land cover, climate change policy, technology, and innovation. And next slide as we wrap up. So in summary, Laura showed that the seasonal forecast can reduce the loss because the intervention strategy is not based only on the forecast, and not all climate factors can influence the standard output. And the conclusions, exactly answering what our user requested of us. Next slide, please. Thank you. So a climate service that correctly forecasts an infection risk 90% with a 90% hit rate should cost between 24 and 36 euros. 70% is 19 to 28, and 50% is 15 to 20 euros. This is very conservative because I was just estimating. Of course, if you really wanted to make a business, maybe you charge more. This was just what I was thinking. And so I think, given the current hit rate of the seasonal forecast, then we approximate an acceptable fee to be about 20 euros per year. And this is given the fee and the distribution of holdings and the maintenance of the dashboard, this is easily feasible. That's what I think to do.
So is this the last slide? Yes. Okay. Thank you very much, Felicidades team. I think we have found very, very interesting your exercise, and I could report the main message, the take-home message from Antonio regarding your work, because you know that Antonio cannot attend today, but yes, some consideration about this work, and he was more than happy because he thinks that you have created a work that could be, in principle, very, very useful for the project and even after the project, and could be something quite useful also for his company. He has appreciated so much the idea of indexing the fee for a possible and hypothetical climate service to the heat rate, and so is brilliant because could be very, very educational for farmer, and the farmer are not used to reason in terms of probability, but if you link the probability with money, maybe something closer to the farmer. And I cannot add more with respect to the consideration of Antonio. I think that you have absolutely touched and hit the target, because and I think that you have acquired the overall idea behind a climate service and the possible commercial viability of a service. And I think that you have very fruitfully merged climate data with non-climate data, in this case the data provided by the company, by the users, in terms of yield, in terms of money, in terms of the size of the graveyard. And so I think that you have done a very good job, a great job. Congratulations. And I hope that, as we say, that you could go ahead with this problem. And if you want to write a sort of short paper on this exercise, we are more than happy to provide you any kind of support. And also, please, if you want to go ahead with this work, please contact also Antonio to get some collaboration and support even from Sograve. I don't know if there are any questions from the audience to the Felicidades team. I know that it's lunchtime, but it is the last mile. Please, Chiara.
Hi, everyone. Actually, more than a question, I would like to congratulate with all the teams. First of all, I introduce myself because I don't think that you've ever met me unless you were in the other session, let's say the previous one, then the last one. My name is Chiara Monotti and I work in the purchasing department in Barilla. So we are inside Mesgold as the industrial partner for the pasta, for the durum wheat sector. So I actually followed with great interest the presentations of today, because I have to say that all the three presentations were very good cases of a direct and practical application of the seasonal and also the long-term forecasts for all the sectors anyway, because you used okay, the olive oil and the wine and the durum wheat as examples, but all the cases that you presented today are actually applicable to all the crops across also the globe. Sometimes we can also consider that these can be actually scalable. So I would really like to thank Alessandro Triacca for the Monica application, in particular for the trial of the fertilization of nitrogen, which was very interesting, and it's also very nice alternative application to what we have also already experimented with Horta. And I would also like, of course, to congratulate Horta for the great support, as well as the one of Massi for this team. I also enjoyed very much Arianna and Tony's presentation for the olive oil sector, because the climate projections would be very, very useful. Also talking about the durum wheat sector, because knowing what will happen in the future in the world and where there could be the cultivation or not of some crops will be very, very important, and not only from an industrial point of view, but also for the undertaking adaptation measures in time prior of things happening. So these would be very, very beneficial in a sense for every application. And again, last but not least, also the group for the wine sector of Laura and Christine. This was a very, very interesting presentation, in particular regarding the costs of the seasonal forecast, because this is something that has to be tackled and undertaken at some point somehow. So it's really, really interesting to see how it was managed in this case. So it was just maybe longer introduction, the one that I've done, but I wanted really to congratulate with all the teams and also the partners who supported them, because I've really seen very, very great jobs done and direct applications to what we are trying to do in MedGold. Thank you all.
Thank you very much, Chiara. I cannot agree more with you. Thank you very much for your comment. And is there any other comment or question for the team? Okay, if it's not the case, I think that I could share the screen for the last time for this Living Lab, because we'll have the final slide. So this is the end, and or not, I don't know, depends. And so this is the end of this event, of this travel altogether, this 5 weeks travel in the climate service arena. This is is a collection of your question, of your key question that you have that you have presented in the first very far session when you present yourself, and this is a collection of all your questions. So I think that now, after we have presented all the methodological framework from the theoretical point of view, but even also in the reality, because the framework, more than 4 plain steps, is something just a little bit more complex. And so now I think that we hope that you can find by yourself the answer to the question you have presented at the beginning of this travel. So let me just say that if you are interested in MedGold, you have all the possible contact, and please join our community and keep in touch for all the other initiative of MedGold, the final initiative of MedGold that could end at May 2022, and also I definitely hope that you want to work on the problem that you have touched in these days, and if you want to go ahead with the preparation of some papers on this. And as we said, we would support very much your this kind of initiative. And please do not forget to fill the survey sent by Marta. However, we'll send all the link for the survey and the other stuff in a final message that you receive in the next hours. So I don't know if there are any other comment or suggestion, or otherwise I think that we can close here the session and the Living Lab.
A big thank to all. It was a really, really pleasure for us to host this event. So a really big thank to all you for your effort and for your time. Thank you very much.
Yes, it has been a pleasure working with you and meeting you all. And we hope that this is not the end of it. So if you need anything, if you want to discuss ideas, chat with us, just reach out and we can look into it.
So
thank you
very much, and
Thanks.
I hope we keep in touch for the future. Thank you very much, and so we can close the Living Lab.
Thank you.
Thanks, everyone.
Bye.
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 Bye.